Hello friends, we will discuss about the X-ray diffractometer and its application and its usage for various kinds of technology. Just you start, this is the X-ray diffractometer equipment, and in this equipment there is an X-ray source, there is a detector, and using this X-ray diffractometer we can determine the various crystal structure such as lattice constant, crystalline size, interplanar distance, and whether the material is formed or not. If formed, it is an amorphous structure or crystalline structure, both crystalline and amorphous. These parameters can be determined using the X-ray diffractometer. Just to start how you prepare this, this is a sample of one of my colleagues. Magnetic materials which are used in various areas of electronic industries, medicines, agricultures. Now how you put the sample for characterization. This is the sample. Just you can see the sample is being placed in a sample holder. Now the sample, the X-rays are being incident on the sample, and just the pattern of this characterization result can be visible on this screen. You can see it. These are the X-ray diffraction pattern of this prepared sample. The sample is a magnetic materials. We can see here these are the patterns which are showing some peaks, the sharp peaks, some more noise-like peaks. This sharp peaks shows the materials is in crystalline structure, and this noise peak shows this is the amorphous structure. So using these peaks, you apply the Scherrer formula 0.9 lambda upon beta cos theta and calculate the particle size. The average particle size can be calculated. We have you use the X-ray wavelength 0.154 nanometers, and the Scherrer formula is being used to calculate the particle size. Yes. This diffraction pattern. This diffraction pattern is on the basis of Bragg's law, 2d sin theta equal to n lambda. On the basis of this X-ray diffraction pattern, this crystal structure can be determined, and these are the references. You can say this material is zinc, iron best oxide, zinc ferrite materials, and these are the references of JCPDS data file, Joint Committee of Diffraction Order Diffraction file, and on this basis we can say that the material is a form, is a magnetic material, and the crystal structure is a cubic spinel structure. And when you calculate the particle size using Scherrer formula, the other parameters such as lattice constant, the interplanar distance can be calculated also. As you know, the relation between interplanar distance and the lattice constant, A equal to d h square plus k square plus l square under root. And HKL using these peaks, and you compare these peaks with ICDD data file, the HKL can be determined, and using this HKL and their psi, you can calculate the other structural parameter. In this way, this X-ray diffraction, this X-ray diffraction is a characterization technique through which you can calculate the crystal structure, the lattice parameter, interplanar distance, crystalline size, and the nature, the phase of a material, whether the material is in a pure phase or impure phase. And what is the importance of this material? We know that the properties of any materials depends upon their purity of a phase, their crystalline structure. Therefore, if you determine, you can obtain the crystalline structure, interplanar distance. Such physical property can be used for various devices development in the science and technology, such as in electronics, in recording media, in iron oxide based industries, in nanomedicines, agriculture, and so on.